Hi, this is Mr. Earnshaw. I'm going to talk a little bit about the computer science A-level as we do it here at FRAM. So first of all, I want to give you an overview of how the course is taught. Now, you'll see there's a big list of topics, from looking at computer hardware and software, looking at the broader issues related to computing, such as legal, moral, cultural, ethical, and other areas, looking at problem solving, algorithms, etc. Now, I say we cover that in year 12, but what we tend to do is we tend to interleave the various topics and try and cover them in parallel so that we can look at complementary areas of different topics. But essentially we are covering the OCR syllabus. There will be a significant programming project which I'll talk about in a moment. But essentially what we're looking at is exploring the methodologies, technology and principles, together its wider impact of the world. We're then going to allow the students to develop their own ideas and skills through design and development of a significant programming project. Most of that work will be done in year 13. The way that the course is assessed is that there are 2.5 hour exams, which is 80% of the mark, one on computer systems and one on algorithms and programming. For those of you who have done GCSE computer science, you'll be familiar with the split in terms of the topics, but the A-level takes them into a little bit more depth, quite a lot more depth actually, and there is a programming project which makes up 20% of the mark, so that's quite different to the GCSE. So the entry requirements for computer science, we're looking for a grade 5 or above in GCSE computer science, or alternatively if you've got a grade 6 or above in GCSE maths, together with some experience of coding. Perhaps you've developed your own games in a text-based language or something like that. Perhaps you've built your own computers and those sort of things, your gaming computers. But we are looking for a considerable amount of programming experience, because that will be difficult to catch up if you've done none before. The complementary subjects is a bit of a difficult one, because traditionally computer science has been associated with maths and other science related subjects, but it's got a very broad curriculum. We're looking at the wider issues related to computer science and how it impacts on the world, so you could argue that almost anything will go with it. I mean, you can look at geography, for example, if you're looking at the environmental impact, or you can look at the social aspects, look at psychology, sociology, in relation to its impact on the broader planet, people, how people work, and also a lot of the careers, which I'll come on to in a minute, relate to soft skills and people skills and the like. So it's not as clear cut as some might think. Higher education wise, if you're looking at a degree, then I would highly recommend doing computer science if you're going to do a computer science related degree. So for example, if you're doing something like robotics or artificial intelligence or programming and development and those sort of areas, then it would benefit you enormously to have done computer science at A-level, particularly given the project. And it's also relevant to engineering courses and other courses involving a lot of planning and problem solving, so you might want to take a look at it in that context. But what I'd always recommend is that you look on the university websites and see what they recommend, and that would be very useful. In terms of careers, now I've said that it's broad. I mean, it's extremely broad. And what's interesting about computer science careers is that since I've been working in computer science, jobs that were never even thought of when I started out, thousands of them have been invented since I've been working in computer science. So it's an interesting area to think about how broad the roles can be. So you can go anywhere from hardware engineering, robotics engineering we've talked about, right through to programming, project management, testing, system support, network management, network architecture, you name it, database architecture, database administration. There are a huge variety of roles, and you can work in any sector, any organisation. Every organisation uses computer science in some way, shape or form. So I hope that's given you a flavour of what we're doing here at Framwellgate School with A-level computer science, and I look forward to seeing you next year. If you've got any questions, then please ask me, and I will try to answer them for you. Thank you.